Recording in progress.
Okay, guys, quiet, please. I'm going to record the homework review and the last notes before we move on to our review for this stuff. Okay, guys, questions about the homework. So you have a whole bunch of problems. You're asked to algebraically solve each of these. There are 9 questions to solve. 10, 11, 12 are evaluating, simplifying log expressions. 13 is expanding, 14 is condensing. 15, 16, 17, 18, 19, 20, 20 are all word problems. So a lot going on here. Here are all the answers. They're already posted to Schoology. Any questions you guys want to ask about that you're confused about that you want to go over? I know it's quite a bit of work. Any of these you'd like to go over? About the word problems? No. Actually, this is not quite complete. Hold on. This answer key doesn't line up.
This is like half the problem.
This is half the problems. Okay, oops. Okay, well, this has a good. Okay. Well, anyway, oops. I thought this answer key was good. Let me make sure the other answer key looks fine for next homework. The next one should be, if someone can turn off the alarm, please, that'd be great. Thank you. Otherwise, okay. Okay, the next answer key should be fine. Anyway, any of these you want to go over at all? No? You guys seem okay? All right. Well, let's just jump to the last section of the notes. So here's the last section. It's just very short. It's on something called regression analysis. You may actually want to have a graphic calculator for this. So if you have a graphic calculator, please take it out. If you need to borrow one, I may have one or two I could blend, or you can look off a neighbor. It's totally fine. But again, we're going to do something called exponential modeling. I don't know if the homework really covers it. Homework just covers the older stuff, it looks like, but. All right, here we go. Let me pull up a calculator myself. All right. Okay, just so you guys know where to go, what I want you guys to do, guys, quiet please, is go to stat, where it says stat, which is right here. After you hit stat, then you want to select edit, which is the first thing you should see. So hit stat, hit enter for edit, and we're going to type in these values you see off to the right. And it's going to take a little while. It's going to be a bit cumbersome, and it personally, actually, it'd be easy to do this in Excel, Google Sheets, just to be honest. But we're going to do this in the calculator just so you know how the calculator does it. So stat, and then just select enter, hit enter right away. And there's actually going to be 17 data points. So you're going to let L1 be the X column. You're going to let L2 be the Y column. So L1 will be X, L2 will be Y. So let's do it. 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. I do have an advantage, I have a keyboard. So I will be faster than you guys, and also I do this for a living. 13, 14, 15, 16, 17. So just type in 1 through 7, and it looks like I goofed on that one. It should be 12. Always double check, because you know we're
these 3 columns.
What's that?
He wants these 2 columns.
No, 2 columns. Yeah. Yeah, because we're letting the year be X will be the number of years after 1986. Okay, 0.392, 0.7652, 1.1835, 1.1. Guys, quiet please. Let's be punching in for stuff. Or you could like help each other out. Like maybe someone could read, someone could punch in. If you want to just do one person. Again, real easy to make mistakes. Your eyes can play tricks on you here.
I'm gonna pull out. You don't like
Oh, I skipped one. Gosh darn it. Ah, that's frustrating. So guys, be careful. I skipped one.
You didn't have someone reading the numbers.
I know. Well, yeah, I know.
No.
Exactly. All right, I think I got it. All right. So once you have it typed in, we're going to create a scatter plot. We're going to find exponential function fits the data, and we're going to express it like this. Okay. So here's what you do. A scatter plot is basically a plot, as implied plot, has a bunch of points that are scattered. So in order to do this, here's what you do. I'm going to go ahead and clear. Actually, hit second mode is to quit. Second mode to quit. I'm going to quit out to the home screen. Now I'm going to hit second y equals. So you hit second y equals, and I'm going to turn on plot one. To turn it on, just hit enter. So it's on. And you want, there's a lot of different plots. You can do like a histogram, a line graph, a box whisker plot. We want a scatter plot. So I want the one at the top left corner selected. And my X list is L1 and my Y list is L2. If you want to change, you can always hit like alpha. Second, like if I did second 4, see it changes to L4, right? But I'll go back to second 2, so L2. Oh, second 2. There you go. And you could have the scatter plot use like boxes or pluses or dots. Pull up to you. And it's turned on now. Okay. So now to actually see it, hit graph. And there you go. Now the problem is I'm not seeing all the data points, right?
For example, what do you think the scale is for this range of the domain is? Yeah, correct. So what's the window? Yeah, I want to go from 0 to 17 instead.
So we could do, and by I'm recording this, so you guys, if you guys are a little lost, I'll do it again, but I am recording this so you can watch it again too. So let me back up so you know what I did. Let me back up a little bit in case you guys are a little lost. So I went to stat, went to edit, punch in the numbers. I'm letting X equal the number of years since 1986. So 87 counts as 1, 88 2, and so forth. The closing price is Y. And then I went to second Y equals. I hit enter, and I turn on plot 1. And you don't have to do anything else. Just turn it on and hit graph, and you get this. So I didn't do that much. It might seem like I did a lot because I went to all these different windows, but I didn't do that much. Now I'm going to go to I'm going to go to window. I'm going to go from 0 to, we'll go from 0 to 20, let's say. And here I'll go from like 0 to like say 50. I'll make the Y scale 5, so the tick marks are not too much of an eyesore. And there you go. So you can see all the data points now. So it looks exponential, right? All right. So that's my scatter plot. So again, to do that, just hit second Y equals and adjust the window. Okay, adjust the window. So there we go. Okay, next up, part B. Find the exponential function that best fits the data. All right, so let's go to stat, calc. So to do this, let me guide you guys. Hit stat, then calc. And then what you want to do is you want to select exponential reg, which is right here. Okay, and you have to tell which list to use, but we know we're using L1, L2 anyway. Now you could store the equation as like y1 or y2, but I'll just hit calculate and just get the equation. Okay, there's the equation. Okay, so the equation is y equals 0.475 do 3 decimal places. Exponential reg. I'll do it again. Don't worry, guys. I'll do it again because I know I'm doing a lot of stuff here. So again, stat, calc, go all the way down to see exponential reg, and go and select it. There's actually a few other ones you can pick too. But yeah, there we go. Okay, now this part that's a little bit tricky. You're asked to express the function in the following form: y equals y sub 0 times e to the kt power. That is a little tricky. So let's think this one through here. So you could do this. Your y sub 0, of course, is 0.475, right? That's your initial value. And you're essentially doing this. You're saying 1, and the k, t and x are the same thing. T and x are the same thing, just so you know. T and x are the same. So what you're doing is you're letting e to the k power equal 1.358. That's what you're doing. How would I solve for k here? What would I do, guys? Yeah, k will equal natural log. Which should be natural log. And it's a little bit rough because I did round a little too soon, but it's okay. So 0.306 we'll say. So now my equation could be this. And sometimes we want in the form of e. Sometimes it's just better to work with that, just depending on some scenarios you have. So y equals 0.475 times e 0.306 raised to the t power. If you want to see if you've done it right, like let's plug in like say 16, for example, and see what we get. Questions so far? If I've gone too fast. Again, I'm recording this so you guys can watch again. We'll do it again. Don't worry. Now I see why these are 2 pages notes, because it does take a little while. Yeah, okay, go ahead.
So why did the e to the power of k is 1.2?
Because we're just rewriting the equation, because originally the equation on the calculator did it like this: y equals a times b to the x. So I'm letting b equal e to the k.
Oh, I see.
That's what I'm doing. Sorry if I glossed over that. That's what I was doing. No, great question. I should have been more clear about that. But yeah, I'm just testing to see if this makes sense now. So let's say I do 0.475 times e raised to the 0.306 times 16. Okay, it's a little off. So be it. It's a little off. That's okay. But if I graph, yeah, go ahead.
So, by doing this, people will make this way. That's the coefficient e with the e to the power.
Yes, correct. So 0.475 times. I'm just going to graph to see how well it fits the data. So it looks like it fits pretty well, and then not so well afterwards, right? So actually, it fit pretty well in the beginning. So let me try one of the points in the beginning. Let me try like 5, for example. So let me go back to the home screen. Let me grab that. And let's switch that to a 5, let's say. Yeah, It's getting kind of close. I mean, it's not perfect, but you know, it's a model, right? But the graph looks like it kind of went to the data points and then kind of veered off a little bit. So that's called exponential modeling. Actually, it's like linear. If you guys have best fit lines in science class, yeah, same. It's the same thing, but you're using a exponential model because that seems to be more reasonable based upon the way the data points look. This is actually kind of the beginnings of like data science, machine learning, regression techniques. It's really cool stuff. If you do want to go that direction, I actually wound up getting a degree in it a few years back. So it's really neat stuff. If that's something you're interested in doing. I already graphed it. Let's predict, interpret the value k. Okay. So again, my equation was y equals. So this we just did, right? So predict the closing price in 2004. So remember, x equals number of years since 1986. So y will equal, was it 0.475 times e 0.306 raised to the 18th power. So
Can you also use the other equation to avoid force?
either one's fine. It's up to you. Yeah, either one's fine.
And will you specify which one will you use?
I will, yeah. So you get 117.16. This is dollars. It looks like it's like a stock price, right? Is that what we're dealing with here? We're dealing with closing price. A motorcycle. Okay, whatever. All right. Now, what if I did the other equation? When we go back to stat again, calc, exponential reg. Now, you could store this, by the way. It's called reg EQ means regression equation. You can store it. If you hit alpha trace, you can call up y1 to y0. Let's store it as like say y2. Okay, there you go. If you go to y equals, you see it's right there. Now, if I hit alpha trace y2 into parentheses 18, you could turn this into f of x notation. The TI4 calculator can do f of x notation. Whatever stored is under y1, y2, whatever, just put in the home screen, put parentheses what you want to plug in. And does in order to call these up, just hit alpha trace to call up any equation you want. That's under y equals. Yeah, I got the same thing, or close enough. It was off a little bit, but yeah. Yeah, I'm doing things fast. Sorry, guys. Go to calc. Same place that we did the exponential regression, but under this option, store equation, you have to hit alpha trace, and you have to choose what you want to store next. That's what you do. So you have to store it. You can choose any one you want. There are 10 options. You don't have to you don't have to hit store. You go to you go down to that field and you hit alpha trace. All right, guys. Now interpret the value k in this problem. Okay, so k, the units. Are years to the -1 power. Because obviously t is in years, right? So that's what k represents. So I'm guessing you could say the price is probably, actually, I'm not sure how to interpret that. Well, t is in years, or x is in years, right? So here's what's happening. So this right here,
K is a constant.
k is a constant, but there are going to be units associated with it. We have k times t, right? So k is in terms of years, so you want those units to cancel. Hopefully that makes a little more sense. No, because I'm trying to understand in context
don't know if it's a rate necessarily.
Or like it's like a percentage, like how much it changes. Like,
per year.
yeah, yeah.
It could be a frequency thing. I mean, it's like half-life or other things. Yeah. Yeah, I guess perhaps you could say that. Yeah, that just doesn't seem 100% clear to me though. Not unlike other interpretation questions. We'll just skip that for now, guys. Let's move on. Okay, next one, guys. Logarithmic and a logistic regression, then we're done. So now that you guys got the hang of this, punch in the data. Do the scatter plot. Let's answer these questions. I'm gonna freeze my screen and work it out. But it'll be recording while I'm doing it. And I'll show you what I have afterwards, okay? And you can overwrite. By the way, let me unfreeze my screen. Oh, sorry. If you want to clear what was under L1, just hit the up key, hit clear, and then down key. It clears it for you. Up key, clear, down key. So it'll clear for you. And let pressure be X and height be Y. So usually the X will be what we call the explanatory variable. Because you're using pressure to explain the height, right? Like we're using years to explain the stock price. Like maybe some years the stock price went up because it was a good economy. Some years when it was down because something happened to the economy or something happened in world events. The Y is always called the response. How it responds to the independent variable. Just so you know.
Which is not the inflation of the lower. It's better than not cash. I think it's better to be see. Yeah. Yeah, no, it's acceptable. That's just company that thinks that they're doing. Oh, yeah.
Are you still going at it? I'm starting to do on Friday. No, I mean preliminary.
Guys, keep working on this.
You need to turn off problems.
Yeah, but I'm pretty sure
Why's your line so solid?
It's a lot. There's a website, it's like baby train.
It might not be logistic. They get like long version.
I don't even know. It was like I search up how much we
No one take China.
Yeah.
No.
Just, yeah. You when you use both of them, then it depends on your first, so.
It's such a problem.
So.
That's like, $560. Yeah, like $800 million.
It's actually.
They're gonna keep raising it up. Okay, we'll forget about that.
Don't think it's gonna happen.
Because we're still going.
Right, here you go, guys. So I'll walk you guys through it. So what you do, guys, quiet down, please. After you hit stat, go to calc, and it's right below exponential reg. It's called ln reg. Sorry, it's right above exponential reg. So it's option 9. Ln reg, right? And does natural log. And I let atmospheric pressure be x and height be y. I guess you could have reversed it. We didn't have to do it that way. But I guess I'm using the pressure as the explanatory variable and height as a response. Probably I should have done the other way around. Probably should have done pressure was y and height's x, but no, it doesn't matter, I guess. So anyway, you did? I could punch it in wrong. Hold on.
I got the same one.
You did? Good job, Aria. I punched mine in correctly, I think. Yeah, mine looks good. I don't know. So, questions? No? Go, Oliver.
Oh, yeah, I got. Yeah.
Thank you. All right, so it could be human error, if you're not getting it. I mean, that's actually it probably is human error. Ln reg. Okay, last one's logistic.
Why don't you do ln a plus bx? What's the difference between those two?
I don't know. Yeah. Let me undo my screen. Well, that's your pressure is 560. You're asking for the height, Catherine. So height's 2.108. All right, next up, logistic regression. So here's what you do. All right, so you just clear. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh boy. 13, 14, 15, 16, 17, 18. Yes. Well, after you hit alpha trace. To store it, you mean? Yeah, alpha trace. Give me a sec. Let me punch it in. Ah, goodness.
Yesterday, he's taking it down. Taking it down. Well, no, it's what.
661. The recommend I'm wrong, right? But this makes no sense. That'd be crazy. Oh, no.
Well, they have, well, they.
Oh, wow.
All right.
If the atmosphere is after and some silence, that's 16 millimeters in mercury.
So I'm doing the last one, guys. It's really taking a sweet little time here.
That's not me. I know. I'm sorry. I was like go to like yeah. So final. That's good.
Wow, that took a long time, guys. Here we go. So equations will be y equals 132. That's what I'm limiting. No, sorry, 656. It's kind of weird because we went over it. 1 plus your a value is 132.6 times e. I don't know. It is a model. Keep in mind, it's a model, so it's not going to be perfect. Okay. Yeah. What's up?
We got.
You know, that could be the case.
I mean, it took forever to do, so maybe it's the algorithm's a little off. We got the same one. Maybe something out there from the same one from the home. Oh, that's in the home? Yeah. Oh, so I like our odds to be.
I don't know. I might punch something wrong. Here, let's see what I mean. I could do something wrong. Hold on. Yeah, logistic. Yeah, 0. You know, I did something wrong. No wonder it freaked out. See, human error, guys. I made a big mistake. So you guys, thank you for correcting me. Keep me in check there. I typed in one of the data points incorrectly. So I'm gonna do this again. Hold on. No wonder it took so long because I think it was freaking out. Okay, let me clear my screen. It might still take a while.
No way. Yeah, 1 plus 7 is minus.
Okay, yes, thank you, Oliver, and yes, because that was weird because the C value was below. Yeah, so okay, I got it now. E negative 0.547, let's say. Yeah, there we go. So if you want to use this, so if we answer the questions now, like create a scar I'll show you in a sec, find that graph, it will do that. What's the maximum capacity of the culture? Probably 663. And then predict at 19, so very easy. If I just go to alpha trace y1 19. Yeah, it gets getting closer. It's obviously a little lower than the data point, but that's okay. You know, it's no model is perfect. 61.57066. If I go to my window, we're going from 0 to say 20. We'll do tick marks of 1. We'll go from 0 to like say 700. Tick marks of 100. We'll graph. And see how nicely that fits? That fits incredibly nicely. That is a really good fit. That's actually an outstanding fit. So yeah, there you go, guys. Okay, so there's your regression 101. There's a lot more to regression in this stuff, but at least you're getting some exposure to it. Trust me, it's ways to do in Excel. Ways to have like a data set to download from somewhere, like a CSV file. And this is not how you do regression. This is like really archaic. But anyway. All right, so now you got some exposure to it. The homework is actually just goes back to section 4 stuff, part 4 stuff. So I'm all done. You guys can use the rest of the time to do some practice, or we got other stuff to do. And then on Wednesday, I'll give you guys details about a test. The test is Friday, right? The test is Friday and the stuff. And then we have one more unit before calculus. We'll do sequence and series after ski week. And then probably sometime in the middle of March or late March, we'll start doing calculus. It's really exciting.